All right, class, greetings of the day. Hoping you all are healthy and happy. Let's begin with today's topic. As you know very well, we have been discussing our chapter number first. Again, we're taking a revision. And in our previous three lectures, we have done very important topics of this chapter. The first one was what is matter? Why do we call it matter? What is the mass, volume of particular matter? Besides this, we have studied what are the three different states of matter like solid, liquid, and gas. Here, we have discussed out what are their various differences between the all three. Moreover, in our previous class, we have just studied, can we change the state of matter from one form to another form? Okay, so we have discussed whether the solid can be liquid to liquid or solid can be converted to gas only. And that we have done with the help of temperature, right? We have seen in our yesterday's class that whenever we talk about the temperature, whenever we increase the temperature, the kinetic energy would be faster, molecules would be start moving faster, and moreover, they would start breaking. Okay, and hence we can say my solid is changing into the liquid. Clear? Now let's move to our second topic, that is effect of change of pressure. In our yesterday's class, I just told you that there are only two methods, there are only two ways how we can change the state of matter from one form to another. Like how I can change my solid to liquid, either by temperature or by the pressure. So our today's topic is, we will see how pressure can be applied, how we use our pressure term to change the state of matter. All right, let's see. See, as you know very well, we have told you that we have increased the temperature so that kinetic energy would be higher. But what would if I apply the pressure, or I would like to say I just compress any kind of gas in a beaker, what would happen? Definitely the molecule would start getting closer. Say particles of gas start getting closer and they would start moving to convert itself into another form. Am I right or not? Suppose I'm taking a short example. Let there is a beaker and I'm applying a piston. This is a piston, that means we are applying pressure with the help of it. This is a piston. Right now, the gaseous molecules are moving away from each other, like, because they have so much space between the two. We have already studied now. Whenever we talk about the gaseous particles, we say that the gaseous particles have much space between them, or there is less intermolecular attraction between the two. Now, if we start increasing the pressure, I'm applying more and more pressure, like this. I'm just grating the pressure more and more. What would happen? My system, or I would like to say this beaker, in which compounds or particles are moving faster due to applying more pressure, they have closed together. Yes or no? As we apply the pressure, as we increase the pressure, I would like to say what would happen? They would easily start getting close to each other, right? And whenever they're getting close to each other, we know according to the definition of solid, liquid, and gas, when a gas has much space between the particles, and I'm saying they're getting closer to each other, that means they're moving to liquid form. Why? Because in liquid form, there is almost no space between the particles. But if I'm talking about the solid, there is almost negligible space, right? So the molecules are getting closer. Their intermolecular force of attraction would have to be strong because they do not have much choice. There's no much space. They have to come closer, right? So meanwhile, keep doing this. What would happen? After some time, when we have applied much pressure, my molecules have become super close. And we can say easily the gas is now converted to liquid. Am I clear or not? So this is how we can say the pressure is used. The pressure can be, the pressure can be used for converting one form to another. Yeah. So this is how, by applying the pressure, the gas can be converted to liquid. Now the question comes to you, which is very important, very crucial question. The question is how a gas can be liquefied. That means how we can convert a particular gas into liquid. And the answer is by applying the pressure or by reducing the temperature. Because if we would reduce the temperature, if we would decrease the temperature, what would happen? They do not have much kinetic energy. So they do not vibrate fast and they do not start getting away from each other. Because we have to make them close to each other. Say the gas is converting to a liquid. Am I clear? So this is a very important question even for your MCQs or for 2 to 3 marks question. How a gas can be liquefied? The simple answer is either by applying pressure. You have seen we are applying more and more pressure and we have converted it into liquid, or we can just reduce the temperature. If we would reduce the temperature, if you would lower down the temperature, the gas would be cooled and it has to be liquefied. Am I clear? Okay, now let's begin with the next topic. We have just done what are the, how can the form of state can be converted from one form to another by changing the temperature, by changing the pressure. Now let's talk about what these three forms are called when they're converting from one process to another. Let's check out a simple way to remember these terms. Let's see. Okay, let's see. We are having whenever my solid is converting to liquid, this is known to be melting, or we can say fusion. In our previous class, we have studied the latent heat of fusion, in which I had told you melting is also named as fusion. Okay, if my liquid is converting to gas, this is known to be vaporization, or we can say boiling. But if my gas, all right, one more point, if my solid is converting to gas, this is known to be sublimation, right? In our tomorrow's class, I have told you that there are many compounds, or we can say there are many examples which can directly be converted from solid to gas without changing into the liquid, right? And we have called them, these are to be sublimes, and the process is known as sublimation. Okay? Now the point is, we have just told them that solid is converting to liquid, liquid is changing to gas, solid is changing to gas. Is the reverse process also true? Definitely yes. We have just seen that either by changing the temperature or pressure, we can easily convert one form to another form. Okay, so if I'm talking about the process in which my solid is converting to liquid is known as melting, but if my liquid is converting to solid, that is known to be solidification. Solidification. Clear? That means my liquid is easily changing into the gaseous process. Same as it is, liquid is converting to gas vaporization, but if we are cooling the gas to make it liquid, this is known to be condensation. Condensation means cooling. Gas is converting to liquid. We are just cooling our gas. Okay. Now, same as it is, as we have studied about the solid, which is converting to gas, as my gas is converting to solid, this is known to be deposition. You have to remember all these names, bache, as these are very important for your MCQs. You can be asked the process of converting liquid into the gas, what is called? You have 4 options. You have to pick out the exact right option. That is vaporization. Same as it is from solid to liquid, from liquid to solid, and many more. All right. So you have to remember this particular diagram. You have to check out which solid is converting to gas or gas is depositing into the solid. Am I clear? All right. Now, one more point I just wanted to show, convey with you. You have seen that the unit of temperature we have studied is degrees Celsius. For example, boiling point of water is 100 degrees Celsius. Now, as we know, if I'm talking about the solid state, if I'm talking about the weight, we know there are so many units like kilogram, gram, pound, ounce, and many more. Okay. In the very same way, as the boiling point of water is known as 100 degrees Celsius, there has been another unit known to be Kelvin, which is represented as capital K. Okay. So we can also calculate our boiling point of water into Kelvin. That is just a separate unit. The boiling point is still the same, but to represent it, the way has been changed now. Clear? All right. So how we can change it? The simple way for converting the Kelvin is by adding degrees Celsius plus 273. This is the simplest formula. You have to keep that in your mind because definitely there will be questions on it. And also you must know about it, that how we can change the temperature from one unit to another unit. Okay, that means Kelvin equals to degrees Celsius plus 273. So if I'm talking about the water, the boiling point is 100 degrees Celsius. The Kelvin would be 100 plus 273, that is 373 Kelvin. That means boiling point of water is now 373 Kelvin. Am I clear or not? Let's see some questions on this topic, with the help of which it would be easy to learn this concept, as well as your in-text questions will be covered. Okay, let's see. Just give me a second. So there have been 3-4 questions in your in-text exercise, which are dependent on the same questions like how to convert degrees Celsius into Kelvin or Kelvin into degrees Celsius. Okay, let's see. The first question is, we have to convert the 300 Kelvin into degrees Celsius. Okay, first of all, we have remembered for converting the Kelvin, we have to add degrees Celsius with 273. Now the point is, we have this is a way how we can calculate the Kelvin. But the point is, the temperature is given in the Kelvin form, and you have to tell the answer in the degrees Celsius form. So this is as simple. If we need to calculate the degrees Celsius, the 273, which is in the positive form, would be equal to negative. Okay, so 300 Kelvin minus 273 equals to 20. We can calculate the or we can say how we can change the unit of temperature from degrees Celsius to Kelvin or Kelvin to degrees Celsius. Okay, this is another point. Clear? Now, moreover, we have the next question, which is known to be, we have been represented the 573 Kelvin, and we have to convert it into degrees Celsius. Same as it is, we would minus it from 273 and we would get 300 degrees Celsius. Clear? Now, the next question is, this is the same question. For any substance, why does the temperature remain constant during the change of state? I'm again repeating the question. The question has been given, for any substance, why does the temperature remain constant during the change of state? But say in our previous class, I had told you something about latent heat. Okay, I have told you that there is a heat which is known to be latent heat. And why do we call it latent heat? Because even the temperature is increasing, even we're applying more and more heat, the temperature always remains the same. And this is the same question, that if we're changing our state, if we're changing our form from one to another, still the temperature is same. And the answer is due to latent heat. Am I clear? The answer is due to latent heat, or we can say this is how, by changing or by breaking the intermolecular force of attraction. Okay, so we can say if we are converting our solid into liquid now, in that particular process, the solid molecules are closely packed. They have the strong intermolecular force of attraction, we need some energy, we apply some heat so that we can dissociate this to become a liquid, because now there is much space. Okay, so we can say either by latent heat, or we can say by breaking intermolecular force of attraction, that heat has been used up. Clear? Now let's talk about the next question, the last one. Suggest a method to liquefy atmospheric gases. How can we liquefy the atmospheric gases? The simple answer I have told you, by increasing the pressure or by reducing the temperature. Any one of these two methods we can use by checking out the liquefaction of gas. Clear? If there is any kind of doubt in this particular topic, you can ask me after the class has been ended in your doubt session. So now let's talk with the next topic, which is today's main topic, that is our evaporation. Okay, let's talk about the evaporation. Okay, now the point here is, suppose I'm talking about, I have just put some water at the outside. There is some water I have put in a pot or in a beaker, and this is a very sunny day. Suppose there is so much heat which sun is emerging out. Now what is happening? After some time, my water starts converting into vapor form like this. Okay, we haven't provided it much energy, we have not provided it so much temperature. पता है कि हमारा जो water है that has 100 degrees Celsius boiling point. Now the point is, I do not have given so much energy, I do not have provided so much heat that it has reached exactly to 100 degrees Celsius. It has not reached. Still the water is converting into water vapors. Why is it so? This particular process in which the water just from the surface, I'm again repeating, any liquid or specifically the water, which is converting into vapors only at the surface, below its boiling point, is known to be evaporation. That means we have not provided that much temperature that it has reached to the boiling point. Still water from the surface area is easily changing into water vapors. That particular process is known to be evaporation. Clear? So in evaporation, the liquid is converting into vapor state only at the surface, okay? Not at the bulk process. Below its boiling point, and that is known to be evaporation. Am I clear? So this is my next topic. What is evaporation and how is it different from the boiling point? Or we can say the process boiling. Okay, but please write down this particular question in your notebook, because this has not been given in your book also, and not in your NCERT text question. Write 2 to 3 differences between evaporation and boiling. The first point is, evaporation is a surface phenomena. Process, I would like to say, not phenomena, that would be a higher word. Boiling is a bulk process. What does it mean? It means that evaporation takes place only at the surface, whereas if I'm talking about the boiling, there is formation of bubbles somewhere. Okay, these bubbles represent that the water is converting all over. If we have 500 ml of water, the all 500 ml of water is converting to the vapor state. It is trying to change its process into the vapor state, but that's not true in the evaporation. Okay, so bulk means in the depth. Okay, the bulk process. Second one, we do not require the boiling point. Only few heat, only small heat would start the evaporation process. But boiling, we need much heat energy so that it reach at its boiling point. High energy is needed. Okay. And lastly, we can say this is a slow process, this is a faster process, and we can say bubbles are seen, but here no bubbles represent. Okay, so this is a very important question. What are the differences between evaporation and boiling? And I'm sure that you have got the concept between the two. What are the differences between the two? This is particular process which is only at the surface, whereas it starts from the deep, and it doesn't require much energy, so it just evaporate from the surface area. Okay, and it requires much heat energy so that my liquid is converting to the boiling point. Clear? To be evaporation. We will see some example how evaporation is used in our daily life. Okay, we will see some effect of evaporation and what are the factors on which evaporation depends. Okay, let's start the next topic. What is the factors of evaporation? And after that, we will just wrap up the class because we do not have much time left by taking your doubts quite obviously. Let's start with the factors. The very first point is surface area. If we increase the surface area, evaporation would be increased. Evaporation would be faster. For example, you have seen, bache, whenever we need to dry our clothes, okay, we just spread them. If we just put my wet cloth and I'm trying to dry it, it would not dry faster. But if we spread it, what would happen? Its surface area is high. It has now a big surface area, so the water present in that wet cloth would be easily evaporate. Okay. So if we need to increase the surface area, the evaporation would be faster. All right. Second point is by increasing the temperature. You know very well, in a sunny day when there is much heat, my wet clothes get dry easily as compared to a cloudy day. Why is it so? Because in a sunny day, the sun is emerging so much heat that the temperature is already high. The clothes which are wet, the water present over them is easily evaporated. Clearly? Now the next point is, we can say, by increasing the temperature, by increasing the surface area. Another one is increase in wind speed. By increasing in the wind speed, the evaporation would be faster. That's why my clothes get dry easily on when the wind is moving with the high speed. And why is it so? The reason is very simple, but the kinetic energy of molecules which are present in the water, whenever we start the speed of wind, what would happen? They would start moving faster because there is an extra force, there is an extra impulsion from the outside. So that the molecules of the water which are present in any type of area, in any type of liquid, I would like to say, they would start moving faster. Their kinetic energy would be faster, and with the increase of kinetic energy, they would start breaking vapor. That means evaporation is faster. Clear? All right. Another we have left with the humidity. We will see that humidity also, and then we will just wrap up the class. The next question, the last one, is humidity. All right. Now, humidity is something which represents the number of water particles in atmosphere. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . suppose I'm talking about the rainy day. There is a rainy day, and after some time, what would happen? In the wind, there are still, humidity in basically known as numbing. Okay, so we can say in the rainy day, even after rain has been stopped, the wind still have the particles of water in it, which are suspended over there. Okay, so what would happen if there is already number of water particles in atmosphere? There is not so much heat because water is something which is cooling the atmosphere. Okay, would the evaporation be higher? Definitely no. Okay, so humidity decreases evaporation. This is the only factor which decreases the evaporation as compared to other one. Okay, so humidity means the numbing, that means water particles that are suspended in the atmosphere. If still there are particles suspended in the atmosphere, that means there is not so much heat, the molecule would not be easy to evaporate. Okay, so this is the point I wanted to explain, the rate of evaporation decrease. All right. So in the next class, we will see how does evaporation causes cooling, or we can say what are the important result of evaporation. Okay, we will see that in our next class. Till now, I'm just going to revise the class within 2 to 3 minutes. First of all, we have discussed that how a gas can be liquefied. And this was done by either increasing the pressure or by reducing the temperature. Okay, and the point is, but say the concept is only the intermolecular force of attraction, the intermolecular force. If you have got the concept, you can easily solve all the questions, whether they are in your in-text question or not. Okay. Second point, we have told about the evaporation. What is evaporation? That is a surface phenomena by the help of which the water present on the surface area would be easily evaporated, would be easily changed into the vapor state. Clear? And we have seen in the last what are the factors on which evaporation are dependent, either by increasing surface area, by increasing the temperature, or by increasing the wind speed. Last one is humidity, which is anti of the evaporation because it means there are a number of particles already present in the atmosphere. Clear? In tomorrow's class, whatever the class would be next, in that particular class, we will see what are the effects of evaporation. But till now, we just need to revise these old topic and try to go through with the chapter because that's very important. And you know very well that on 9th of June, you have the UT1. So revise very carefully. You can ask me.